Number 65. Calculate the formal charge of each element in the following compounds and ions. And then we have A through H. Okay, so we did a couple of questions that deal with formal charge. If you want a more in-depth version, you could always go back to see those. I think they start at number 62 or 63. So if you're on the playlist, you could just hit the back button a couple times. And yeah, so I just want to say that there's two things that we need to know how to do to get the formal charge for each element. The first thing is, and probably the most important one, is know how to draw the Lewis structure for the compound. So for each one, you're going to have to draw the Lewis structure for A through H. So if you're not strong with your Lewis structures, try to do those first and get proficient at those, and then you can tackle these. But if you're not strong, that's totally fine. You could always go back to, I think question 40 starts Lewis structures that we go into depth with in this chapter. And I'll be there every step of the way for you guys. And I am sure that you will get better at those. So we got to know how to do those. So I'm going to assume that we know how to do the Lewis structures here. And then the second thing is we just have to do the formal charge formula. Now they give you a formula in the textbook. I don't really like that one. I don't know. There's an easier one. So I like to use this one, which we will use when we do the actual questions. So if you want to memorize this formula and then use it, that's fine with me. So here we go. So A, we have F2CO. So you can pause the video and see if your Lewis structure that you created is the same as mine. And if it's not, maybe you just need to be a little bit more stronger in Lewis structures, but that's totally okay. So the Lewis structure for this guy would be 2 fluorines, chlorine in the middle, and then an oxygen. There would be 2 bonds, and the fluorine has 3 lone pairs, and the oxygen would have 2 lone pairs. The chlorine is cool. Sorry, not the chlorine. The carbon. I'm sorry if I said chlorine before I meant carbon. This is a carbon. Okay. So it looks like they want it for each element. So we're going to have to find out the formal charge for the fluorines, the carbon, and the oxygen. Okay. Now, if you see that an atom looks exactly the same, you only have to do the formal charge for one of them, and then you can just say that the other one would have the same exact formal charge. So for example, this fluorine would be the same as this fluorine because each one has 1 bond and each one has the 3 lone pairs. 3 lone pairs. So I could only do the formal charge for one of them, and then we would know the formal charge for the other one. So in this case, we have to do the formal charge for oxygen, the formal charge for carbon, and then the formal charge for 1 fluorine, and then we would know the other one. I'm just going to say that this is FC. Okay, so let's do oxygen first, going by the formula that I put up top here. So the formal charge is always for an individual atom. That's why we have to do oxygen, carbon, and fluorine separately. So for oxygen, it's going to be the valence electrons of that atom, which is found on the periodic table. Oxygen has valence of 6. So that's the first number that you're going to put here. 6 minus the number of bonds. So how many bonds do you see? I'll put the minus sign over here. How many bonds do you see that this oxygen has? Well, it has 2, right? It has this bond and it has this bond. So that's 2 of them. So 6 minus 2 minus, now how many dots, right? Minus the number of dots, which are lone electrons. So for oxygen, you have 1, 2, 3, 4 dots. So I'm going to say minus 4. So 6 minus 2 minus 4 is 0. So this oxygen right here would have a 0 formal charge, a 0 charge, which means that that oxygen is classified as stable. And that's all that these formal charge are telling you, whether your atoms would be stable or unstable depending on if it has a charge or not. So next, we have the formal charge of a carbon. This one. Start with the valence electrons. Carbon has a valence electron of 4. So we'll say 4 minus number of bonds that you see that carbon has. Well, how many bonds are surrounding this carbon? Well, it has 1, 2, 3, 4. So that's 4 bonds. Minus number of dots. There's no dots around carbon, right? You don't see any lone pairs like that. So that's a 0. And then when you subtract them, they equal 0 as well. Formal charge for the fluorine. So let's look at this fluorine, right? So fluorine has a valence of 7. You always start with the valence. So it'd be 7 minus, how many bonds does this fluorine have? It has only 1 bond. So that's a 1 minus how many lone electrons? Or how many dots? 1, 2, 3, 4, 5, 6. So that's minus 6. And that would equal 0. Everything here is equal to 0. That's why there's no charge in the upper right-hand corner. If there were charges, that means that some atom has to have a 0 charge. Now, what I'm going to do over here to make this question go a little faster is, if you know the formal charge for a certain atom and what it looks like, it will always be the same. So I'm going to say here that an oxygen with 2 bonds and 2 lone pairs always has a formal charge of 0. So I'll just say here, actually, just to not confuse you, we'll say that. So anytime you see oxygen having a formal charge with 2 bonds and 2 lone pairs, that will be a 0. Carbon is 4 bonds, 0 lone pairs. So I'm just going to put over here like this. Now, does it matter if it's a double bond and 2 single bonds? Absolutely not. It just has to have a total of 4 bonds and no lone pairs. The formal charge will be 0. And the same thing for fluorine. Fluorine with 1 bond and 3 lone pairs, like we've seen in this example, has a formal charge of 0. So we'll reference those if we need to. All right, so A is done. Moving on to B. B has NO minus. Negative means that it's a -1, so someone has to have a charge. Now, let's do the Lewis structure. So pause the video if you want to try the Lewis structure on your own, but the Lewis structure should be nitrogen, double bound to oxygen, and each one of them has 2 lone pairs. And since it has a charge, you have to bracket it and put that charge in the upper right-hand corner like that. Now, we already know one of the charges from what we did before, which we just said over here, right? Oxygen with 2 bonds and 2 lone pairs, right? You see that? Over here, you have 1 lone pair here, 2 lone pairs, 1, 2, total of 4 electrons, and 2 bonds will always have a formal charge equal to 0. And that's what this is. It has the 2 lone pairs and the 2 bonds. So we already know that the formal charge for oxygen would be 0. And you guys can try the math out if you want. Now let's try the formal charge for the nitrogen. So valence electrons, nitrogen starts off with 5. So it would be 5 minus, how many bonds does this nitrogen have? Oh, well, it has 1 and 2. So 5 minus 2 minus number of dots, which is the lone electrons. How many dots does nitrogen have? 1, 2, 3, 4. So minus 4. 5 minus 2 minus 4 is the -1. And that's how you get the -1 in the upper right-hand corner. This oxygen was a 0. If you sum up all the formal charges, 0 plus a -1 is a -1, and that's how you get that charge in the upper right-hand corner. So there you go for that one. The formal charge of oxygen was 0. The formal charge of nitrogen was the -1, and B is done. Now let's move on to C. So what I'm going to do is I'm just going to erase some of this. Let's see, maybe I can get most of it. Okay, that's good enough. I'm just going to erase the other ones so we have the most space here. I can just take that out. Okay, cool. Now let's do C. B, F4 minus. There's a charge, which means that some atom, or, a couple of atoms have charges, and it has to equal to -1. You could pause the video if you want to try to make your own Lewis structure, but this one would be boron in the middle, surrounded by 4 fluorines. That's a little ugly. Okay, 4 fluorines. And there's no lone electrons for boron, but each fluorine has the 3 lone pairs like this. 6 lone electrons, 6 dots. Okay. Now, from our list that we have made before, do we know a formal charge for an element? Yeah, right? We've done a fluorine with 1 bond and 3 lone pairs always has a formal charge of 0. And look what we have. A fluorine with 1 bond, 3 lone pairs. And the same thing for all of these. This fluorine, and this fluorine all have 1 bond and 3 lone pairs. So we already know the formal charge for those fluorines. The formal charge for this fluorine is 0. Formal charge for this fluorine is 0. Formal charge for this fluorine is 0. And the formal charge for this fluorine is also 0 because we've done it. But if you want to do it again for practice, go for it. You'll see that it's 0. Now we just have to do the formal charge for boron. So, start with your valence electrons. Boron has a valence of 3, so it would be 3 minus number of bonds. How many bonds does this boron have? 1, 2, 3, 4. So 3 minus 4 minus number of dots. Is there any dots around this boron? No, right? There's no dots. You don't see any dots like that around the boron. So that would be 0. 3 minus 4 minus 0 is -1. And there is the -1 charge. It comes from the boron. And if you add all these up, 0 plus 0 plus 0 plus 0 plus a -1 is the -1 charge. So that checks out. And that's done. Next, D. SnCl3 minus. There's a negative charge, which means that somebody has to have a charge. And let me draw it. So we have tin, which has this. We have 3 chlorines like this. Each chlorine has the 3 pairs around it. And then tin should have 1 pair like that. And since it has a charge, it has to be bracketed and a negative charge over here. The same thing for BF4. It should have been bracketed with a negative charge. Okay. So now let's go for it. We didn't do chlorine and we didn't do tin, so let's just do them both. Now for the chlorines, they look like there's 3 of the exact same ones. Each chlorine has 1 bond and 3 lone pairs, right? This chlorine has 1 bond, 3 lone pairs. And this chlorine has 1 bond, 3 lone pairs. So we just have to do one of them and the others will be exactly the same. So formal charge of Cl and then formal charge of Sn. I'll put that in lowercase. Okay. So let's start with the chlorine. Chlorine has a valence of 7. So 7 minus number of bonds that this chlorine has. Well, it just has the 1 bond. So it'd be 7 minus 1 minus number of dots. 1, 2, 3, 4, 5, 6. So that's a 6. 7 minus 1 minus 6 is 0. So that means that all of these would be 0. Formal charge of chlorine, 0. Formal charge of Cl is 0. And then tin. Tin is over here. Sn has a valence of 4. So this would be 4 minus, how many bonds does tin have? 1, 2, 3. So that's a 3 minus, how many dots or how many lone electrons? 1, 2. So that's minus 2. 4 minus 3 minus 2 is a -1. And there's where that -1 charge comes in. So it checks out. So this would have a formal charge Sn of a -1. Perfect. I'm just going to add to the list here. Chlorine with 3 lone pairs and 1 bond has a formal charge of 0. And if you just memorize these, as you know, oxygen having 2 bonds, 2 lone pairs is neutral, which means 0, formal charge of 0. Carbon with 4 bonds is 0. If you memorize these, they will always be the same. There's never going to be a day where carbon with 4 bonds would be a, -1 charge. So that's also good, especially if you guys are going into organic. It's much quicker to memorize the charges instead of doing the formal charge over and over and over again. Okay, so that one's done. Now let's just erase some of this. Okay, let's erase this. And we shall proceed. 50% done, but it should be easier because now we have a list of our 4 of them at least, right? So maybe it'll go a little quicker, but let's see. H2CCH2. If you want to try your own Lewis structure, pause the video, but it should be 2 hydrogens bound to a carbon, and in this case, this carbon will be double bound to the carbon, and then 2 hydrogens, because we have to fulfill the octet rule. Now, it looks like all the hydrogens are exactly the same, right? Each hydrogen has only 1 bond, so I only have to do 1 hydrogen and know the other ones. And technically, let's look at these carbons, right? So let's look at this carbon. How many bonds does this carbon have? Well, this carbon, right, this one over here, has 1, 2, 3, 4 bonds. 4 bonds, so I'll just say 4 bonds, 0 electrons, so 0 dots, we'll say, 0E. Did we know that one? Oh yeah, look at this. A carbon with 4 bonds, no lone pairs, always a formal charge of 0. So, we already know that this one will have a formal charge of 0. Doesn't matter whether it's a double bond with 2 single bonds or a triple bond with 1 single bond, just as long as you can spot out the 4 bonds. But if you did the actual math for that, it would come out the same. And the same thing for this carbon. There's 1, 2, 3, 4 bonds with this carbon. So that already we've done. That one has a formal charge of 0 because of what this said. Now let's just find out for the hydrogens. So formal charge for hydrogen is hydrogen has a valence of 1. So 1 minus. Now let's take it for this hydrogen. How many bonds does that hydrogen have? Oh, it only has 1 bond. I can't take these because they're not attached to this hydrogen. So it'd be 1 minus 1 minus, are there any dots surrounding this hydrogen? No, right? You don't see any dots here. So it'd be 0. So formal charge of this hydrogen is 0. So formal charge of hydrogen is 0. This one would be exactly the same because it literally looks identical. All of these would be exactly the same. And then we could make that generalization. Anytime that you have a hydrogen, I'm going to put it over here. Let me just make that a little bit, that's a bond though. Anytime that you have a hydrogen with 1 bond, the formal charge will be neutral, 0. That's another one that you could kind of memorize instead of doing the formal charge over and over and over again. So that's E. Next, we have F. ClF3. You could pause to see if you could make your own Lewis structure, but it should be chlorine in the middle, surrounded by 3 fluorines. I'll just say 1, 2, 3. Each fluorine should have 3 lone pairs. And the chlorine should have 4, 5, 6, 7. There you go. Okay. So now there's 2 different types of elements here. There's fluorine and there's chlorine. And each fluorine looks exactly the same. But even better, right? This fluorine has 1 bond and 3 lone pairs. This fluorine has 1 bond, 3 lone pairs. And this fluorine has 1 bond, 3 lone pairs. Do we know already if what the formal charge will be when a fluorine has 1 bond and 3 lone pairs? Yes, we do. The formal charge is 0. So we've already done this one. Formal charge of this fluorine would be 0. Formal charge for this fluorine would be 0. And the formal charge for this fluorine would be 0. The only one that's different is this chlorine. Now, it's different from the one that we have because this chlorine has 1 bond and 3 lone pairs. This one has 3 bonds and 2 lone pairs. So it could be 0, it could not be 0, but we should just check just in case. Chlorine has a valence of 7, so you start off with 7 minus the number of bonds. Chlorine has 3 bonds attached to it, minus the number of lone pairs. 1, 2, 3, 4, minus the number of dots, not lone pairs. You don't take it and say that there's 2 lone pairs. You actually count how many dots. So there's 4 dots, 4 lone electrons. So 7 minus 3 minus 4 is 0. So this chlorine would also be 0. So it could have many different forms. It could look like this, or it could have those 3 bonds, but ultimately both of them would be a formal charge of 0. So that's F. Next, let's just get rid of this one, and let's just see if I can... Okay, cool. Almost there. G. SEF6. You could pause the video to see if you can do the Lewis structure by yourself, but you should have selenium in the middle, surrounded by 6 fluorines. 1, 2, 3, 4, 5, 6. And each fluorine should have the 3 lone pairs. I'm just doing this quickly for you guys. But they should all look exactly the same. And as I draw this, what do you think? Do we already know the formal charge for these fluorines? Yeah, because they're all the same. And a fluorine with 1 bond and 3 lone pairs is always a formal charge of 0. Well, look here. Fluorine with 1 bond, 3 lone pairs. Fluorine with 1 bond, 3 lone pairs. And you can see that each fluorine has the 1 bond and the 3 lone pairs. So for each one of these, we've already done this one. It all would equal 0. Formal charge of fluorine would equal 0. Formal charge of fluorine, 0. 0. Zeros all around. Now we just got to do the selenium in the middle. So let's try that one. Formal charge of selenium. Start with valence electrons. Selenium's over here. Valence is 6. So it would be 6 minus the number of bonds. Selenium has 1, 2, 3, 4, 5, 6. So that's 6. Minus, how many dots do you see that this selenium has? There's no dots around selenium. So it'd be 0. So 6 minus 0 is 0. And the formal charge for this selenium is 0. And if you added up all the charges, it would equal 0. And that's why there's no charge in the upper right-hand corner. Last one. And it looks like they have saved the best for last. PO4 3 minus. Okay. 3 minus. There's probably a couple of charges going on here, but let's see. So what we can do is we can put phosphorus in the middle, and there's going to be 1 double bond. And then in this case, there should be 3 single bonded oxygens, and each one has 3 lone pairs. Okay. So there you go. It has a charge, so that means that it has to be bracketed and put a 3 minus or a negative 3 in the upper right-hand corner. Do we know the formal charge for one of these atoms? Yes, we do. It's actually this one, because we know that oxygen with 2 bonds and 2 lone pairs always has a formal charge of 0. And that's what this oxygen has, 2 bonds and 2 lone pairs. So we automatically know that this has a formal charge of 0. I can't say that for these oxygens because these have only 1 bond, so they are different from the other oxygen. However, they're all the same because each one of these has 1 bond and 3 lone pairs. So I could just find out 1 oxygen and I will know the other 2. So let's try that out. Formal charge of the oxygens equal. Oxygen has 6 valence electrons, so that's 6 minus. We'll talk about this oxygen. How many bonds does the oxygen have? Well, it's just attached to 1. So it'd be minus 1. Minus, how many number of dots? 1, 2, 3, 4, 5, 6. Minus 6. 6 minus 1 minus 6 is a negative 1 charge. So this formal charge for this oxygen will be a negative 1. This formal charge for the oxygen would be a negative 1. and this would be a -1. Now we just got to figure out what the phosphorus is in the middle. So, formal charge of phosphorus is over here, has a valence of 5, minus, how many bonds does this phosphorus have? Well, it has 1, 2, 3, 4, 5. You count the double bond twice, so it's 5, minus, how many dots? Does this phosphorus have any dots or lone electrons? No, right? There's no dots that you see here. So it'd be -0. So 5 minus 5 minus 0 is 0. And the formal charge for this phosphorus is 0. And we are done. Whew, this one was a big one, guys. So, a lot of things to take away from this. You definitely need to know your Lewis structures. That's without exception. Then we need to know that formula that we've constantly used, this one right here. And also, try to put things in generalizations. You will get faster and you won't spend as much time doing the formula if you memorize the neutral compounds. But if your teacher or professor wants you to actually see the math, then obviously you got to do it. But yeah, other than that, this one was fun. What do you guys think? Thank you so much for joining to the end. If you want, you can hit the subscribe button, tell all your classmates and anyone who needs help in chemistry. And if you know people that are having trouble in physics, my brother is doing the physics course right now. So if you guys need that, we got you guys covered. Thank you so much. Have an awesome day. Happy studying.